Welcome to Module 2, Video 6, from the Safe and Effective Use of AI in Education online resources.
A significant concern about the use of generative AI is around sustainability. Training large AI models requires enormous computational power. Then, once AI systems have been trained, their ongoing operation, every query, every interaction, also uses energy. Millions of daily users create substantial cumulative demand, with AI models receiving billions of queries every day. On an individual level, we need to be aware of the sustainability implications of AI use, and, as with any other technology, decide each time we use an AI system whether it's really the most appropriate tool for the job. We should be aware that different tools producing different outputs use varying quantities of power. For example, asking an AI tool to recreate a video several times until it's right will use much more power than multiple prompts for a text output. It's worth considering our prompts more carefully when producing large and complex outputs to limit the need for multiple iterations. The kind of model we use also makes a difference, with more basic models being less resource-intensive than so-called reasoning models. Most large-scale AI models do not run on individual devices and instead rely on extensive computational infrastructure. When a user submits a query, it's typically sent to a remote data center that stores the AI models and uses thousands of specialized processors working in parallel to perform the calculations required to generate a response. This centralized approach allows powerful AI to be accessible from almost any device, but it creates a concentrated environmental impact. Data centers use significant amounts of water for cooling the processors. In water-stressed regions, this raises serious equity concerns about resource allocation. As AI data centers operate continuously, they require constant electricity for both computation and cooling systems. These facilities can consume megawatts of power, often sourced from electricity grids still dependent on fossil fuels, contributing to carbon emissions. One difficulty when trying to assess the environmental impact of AI development is being able to find out data about how different tools affect it, and there is considerable debate about how to fully capture the energy use of AI from training through to deployment.
However, looking ahead, as AI systems mature, they are likely to become more efficient. The way models are created and run will be less energy intensive, especially with moves towards smaller, more bespoke models to meet specific needs rather than huge all-purpose systems. This transition is already underway, alongside growing interest in running some AI systems locally on users' own devices, rather than relying solely on large, centralized data centers. Even within those data centers, technology is being developed to improve the efficiency of the cooling systems, and the faster you can cool water in a data center, the less of it is needed. More simply, an AI data center built in a location with an abundant water supply and powered by clean energy would have a significantly reduced environmental impact. In the meantime, we can consider making individual choices to reduce the environmental impact of our digital lives by using AI responsibly. Where appropriate, we might choose to use a more lightweight tool for a routine task rather than a large-scale language model in energy-intensive reasoning mode. Effective prompting means we don't have to keep re-prompting with more detail, and grouping queries together can help to reduce the overall processing time.